All right, welcome back. In this lesson, monitoring network I/O activity, we're here to take a look at the networking metrics that we can monitor in ESX Top. All right, our goal here is to determine, first of all, which networking metrics to monitor and which metrics in ESX Top we're looking at, and finally, monitoring the key network performance metrics, right? We're looking for those key performance indicators. So when it comes to networking, though, that's actually an interesting area here because we definitely want to look at I/O, networking I/O, as it passes through the virtual machine's virtual NICs, because we'd want to be able to measure the network usage coming in and out of a virtual machine. So you can look at your network throughput through the virtual NICs. In fact, in looking at the different layers, we've got the virtual NIC layer. We also have the physical NIC layer because it may be also useful to find out if you've got a high consolidation ratio on your ESX server, what's the network usage coming in and out of your physical adapters. ESX Top can show us from both perspectives, in fact, all on the same screen. So for virtual machines, we actually have several key performance indicators. We're going to be able to look at network bandwidth being used per virtual NIC. So there may be a case where we're looking for how many of the bandwidth coming out of each of the different virtual NICs, and then measure the packet count is another thing that environments may need to be monitoring for, right? Counting packets, though, is not as useful unless you know the packet size, because counting packets that are 100 bytes in size is a whole lot different than counting packets that are 1,000 bytes in size. So we want to also get the average packet size, which of course ESX Top can give us both of those numbers. And then finally, we want to be able to measure drop packets because we don't want to see any drop packets. So that's an important metric to monitor. So we want to be able to measure that from the VM and seeing what kind of throughput we're getting out of the VM as it's passing through the VM and on out to the rest of your physical network. But we certainly want to measure the same thing on the physical NICs too, because if two VMs are using this adapter, the network throughput is going to be quite different than having one VM using this adapter. And then if this one is completely idle, it's not going to be using any bandwidth at all. So we want to be able to measure the bandwidth per physical NIC, measure the packet count and average packet size again through those adapters, and then also be able to measure the drop packets. Another important measurement is to identify which of the different VM's virtual NICs are actually bound to which uplink, so that we can see here that our first two VMs are actually using different uplinks, but our third VM is sharing the same uplink as the first VM. Being able to measure that can also help determine what actual network utilization we've got available to us. So those metrics, right, we kind of gave a description to them. What are the actual key metrics that we can see? Well, of course, we really want to watch out for those drop packets. But we also want to be able to measure things such as network usage, packets transmitted, packets received, average packet size, and also measuring the received packets dropped and the transmit packets dropped, because they mean different things. Why would I be dropping transmitted packets as opposed to why are we dropping received packets? Completely different scenarios here. So opening up ESX Top and selecting the letter N will take you to the networking screen. And the networking screen comes with almost all the parameters, all the different columns that you'd want are pretty much part of the default screen. However, to note here, what we have, there is the variety of different counters. The data transmits, that's the megabit, MBTX and MBRX, right? You can measure your megabits transmitted and received both from a virtual NIC and from a physical NIC. You have the PKT, the packets, PKTTX and PKTRX for your packet counts, both transmitted and received. And there's also PKTSZ, not shown here, but that's the packet size, both transmitted and received. And then there's also the dropped TX and the drop P and RX. Those are your drop packets. So important metrics they're available in the entire networking view. Now, the thing with the networking view is it's actually a little bit different than all the other views. Usually the item that we're monitoring is on the left-hand side of the report, right? The left-hand column or near the left-hand side of the report will show you the thing that we're looking at. But the thing is, when it comes to networking, there's actually probably several things we might be interested in looking at. We might be interested in looking at a virtual machine. We might be interested in looking at a VM kernel port. We might be interested in looking at a physical adapter. Well, that's what use by represents. Use by is the thing that we are interested in looking at. However, it's not organized by those. It's actually organized by the D name. That's the device name column. And that's usually how these reports are. They're usually organized by some kind of device name, right? For instance, in the storage views, there's the LUN view, which shows you the LUNs on the left. Then there's the adapter view, which shows you all the HPs on the left. Here, the thing that we're looking at is mostly based on the switch, right? So we have a whole set of vSwitch 0 based objects, and we have a whole bunch that are associated with a distributed switch. One thing about distributed switches, notice the name here. It says DVS port set 0. The vSwitch, the standard switch, actually has a proper name, right? vSwitch 0, vSwitch 1. But for distributed switches, they're not going to be listed by the distributed switch's name, mostly because the ESX server doesn't know what the name is in the first place. Right? An ESX server is really just a member of a distributed switch that's actually saved and stored in the vCenter repositories, right, for its own inventory. So all the ESX server knows are the ports that are associated with this switch. It's basically a set of ports. So it's known as a DVS port set with a whole set of parameters. And remember, a distributed switch creates a hidden virtual switch on the ESX server that doesn't have a name, so we can't see it. And so ESX top basically says, yeah, we've got a bunch of ports that are all associated with the same switch. So they're port set 0. If you happen to have more than one distributed switch that this ESX server is a member of, then you'd see DVS port set 0 and then another DVS port set 1. That can be a little tricky. You'd have to actually go and just verify that here's a virtual a VMNIC. You'd have to go into the vSphere client and just find out what VMNIC is associated, which distributed switch is he a member of. And then you can very easily figure it out through this report. But what do we have here, right? We can see the collection of items that are on vSwitch 0, the collection of items that are on distributed switch. The use by tells us everything though, right? If I want to measure the networking throughput through a physical adapter, it's listed here, the actual physical adapter. And here we have our packets transmitted, our megabits transmitted, our packets received, our megabits received, and so on and so forth. They all got cut off here. We can see the VM kernel port, which is currently bound to the VMNIC 0, right? Well, this is actually pretty easy to tell. We can see both our VM kernel port and our VM are both mapped to the same physical adapter. Well, because this virtual switch, vSwitch 0, only has one physical adapter. So this is pretty obvious that they're going to be using this adapter, but we can see here that these two values, the amount of packets transmitted by the VM and the packets that are transmitted by the VM kernel port, add them together, and that's what's going out of the actual physical adapter. Same thing on our other distributed switch. We have VMNIC 1, which is on the distributed switch, and then we have our test VM 01, which is on the distributed switch, who is bound to VMNIC 1. And so these numbers, since it is apparently the only thing on that switch, these numbers are the same. But looking carefully at these numbers, you might find it is a little interesting that a number over here, we have our packets of received, 4926, and over here, the packets transmitted are 4926. I wonder who's talking to who, right? If they're on different virtual switches, they have to go out to the physical network and then come back in. Those numbers are suspiciously the same, aren't they? So you have a lot of interesting metrics here, and it's very useful to make sure all the columns that you're interested are actually on a terminal window that is wide enough to show them all, because in our example here, they are obviously they can't fit here, which is unfortunate. Now let's see, one other thing to note, if you are looking at any modern system of today, any modern ESX server of today, you'll probably find there will be additional adapter objects, which can be a little confusing, right? You'll see these shadow adapters. Shadow adapters for every one of the physical adapters, right? You'll see shadow adapters for VMNIC 0, a shadow adapter for VMNIC 1. It just, what I find it basically crowds the display a bit, because we're trying to figure out what the heck is a shadow adapter, right? It doesn't give you anything additional in terms of your knowledge or finding out what it is about the network. But what it is, it's actually all about health check. Health check, remember, creates a whole new set of MAC addresses to then verify the connectivity to the network through somewhat of an actual virtual adapter. And so those shadow adapters are in use by health check. So there's no easy way to turn them off. I mean, technically you can, but just be mindful there'll be additional shadow adapters. They're there because of health check. So that was a quick look at the actual report, let's take a quick break, and we're going to take a look at the other impacts of drop packets. So we'll take a quick break, and we'll come back in a few minutes.